Imagine buying a brand new, like $80,000 electric vehicle. You are cruising down the interstate, the dashboard is completely silent, and you're just enjoying all that instantaneous torque.
Yeah, living the dream right up until...
Right, until you miscalculate.
Yeah.
You run out of juice on the side of a busy highway, so you call for help, and 30 minutes later, the rescue truck pulls up, the technician hops out, and saves your state-of-the-art, zero-emission supercomputer on wheels.
By firing up a roaring, vibrating, gasoline-powered generator.
Exactly. It's wild. Welcome to the Deep Dive. Today we are looking at how the EV industry is trying to solve its absolute biggest bottleneck, which is charging infrastructure. But they're not doing it by forcing you to go to the charger. They are bringing the charger directly to you. Okay, let's unpack this.
We actually have a fascinating stack of sources to guide us through this today. We're pulling from an industry report on the EV landscape shaping 2026 from BeeCharged. We also have highly detailed product specs from mobile charging companies, specifically SparkCharge and FreeWire, plus comprehensive service evaluations from AAA's latest mobile charging pilot program.
Which are so interesting. And we have real-world data and pricing models from BeeCharged EV and the Currently app. So the mission today is to explore this massive shift toward what people are calling charging as a service.
Yeah, because the very geographic relationship of driving is just getting completely turned on its head.
It really is. I mean, for over a century, the ritual of driving has been anchored by the gas station.
Right.
It's concrete, it's rooted in the ground, and you have to go to it.
Right, you go to the fuel.
Exactly.
That's it.
But we are moving into this era featuring everything from high voltage, like Lego block batteries you can order from your phone, to the fascinating irony of those gas-powered roadside EV rescues I just mentioned.
Yeah, and to understand why this mobile revolution is happening at such a breakneck pace, we really first have to look at the sheer scale of vehicle engineering coming down the pipeline by 2026.
Because the cars are getting wild.
They really are. The BeeCharged report lays out this staggering picture of where automakers are directing their capital. They're no longer interested in just incremental changes to battery efficiency.
Right, like an extra 10 miles here or there.
Exactly. They are prioritizing massive, undeniable capabilities. We are talking about 350 to 450 miles becoming the baseline driving range.
Which, I mean, that effectively cures everyday range anxiety for the vast majority of drivers out there.
It does. But, to support batteries of that physical size, the manufacturers are pushing for 600 kilowatt, 800 volt charging systems.
That is just an immense amount of power.
It's massive. It's being blasted into a vehicle in a matter of minutes. And furthermore, the industry is finally standardizing. The North American Charging Standard, or NACS, is becoming universal across almost all major brands.
Which is essentially just the industry waving the white flag and adopting Tesla's sleeker plug design, right?
Yeah.
So nobody has to carry around those heavy, cumbersome adapters in their trunk anymore.
Precisely, yeah. And behind the scenes, artificial intelligence is now actively being used to develop new, highly durable battery materials.
Okay, wait, I have to jump in and push back on this entire premise.
Oh, go for it.
Because, okay, we're building these incredible software-defined vehicles, right? Cars that get over-the-air updates like a rolling smartphone. They have universal plugs, AI-designed batteries, and massive ranges.
Yeah.
But we can't actually plug them in anywhere because traditional permanent chargers require grid upgrades that take months or even years to complete.
Yeah.
So aren't automakers just building supercomputers with literally nowhere to plug them in? It seems entirely backwards.
I hear that argument constantly, and it seems illogical on the surface, but look at it from the automaker's perspective. They actually have to push the vehicle's battery limits first to force the grid's hand.
Oh, interesting. So it's intentional.
Yeah, well, if automakers waited for local municipalities and utility companies to naturally upgrade the electrical grid, we would never transition. The capability of the vehicles must outpace the infrastructure to create an undeniable market demand.
So they're basically betting that if they build a 400-mile car, the market will just figure out how to charge it.
Exactly. And the Blink report highlights just how far behind that infrastructure really is right now. Transportation electricity demand in the U.S. could jump from, get this, 0.2% to 23% by 2050.
Wow. Yeah, you cannot just flip a switch and make a 100-year-old power grid handle that kind of load overnight.
You really can't.
No.
Upgrading a traditional fixed charger site involves getting permits, trenching through solid concrete, upgrading local transformers.
It sounds like a nightmare.
It is a massive capital expense. A single fast charger installation can easily stretch into an 18-month ordeal. So because fixed infrastructure is lagging so far behind vehicle capability, an entirely new industry has emerged practically overnight out of sheer necessity.
Mobile charging.
Mobile charging, exactly.
So if you can't get the grid to the cars fast enough, you have to basically decouple the charger from the grid entirely. Which brings us to what I like to call the jerry can of the EV era.
I love that analogy.
Let's talk about SparkCharge and their portable charger, which they call the Roadie. This thing is fascinating from an engineering standpoint. It essentially looks like a large, high-tech carry-on suitcase.
Yeah, it's incredibly modular.
Right. You have a battery module that weighs about 70 pounds and a separate charger module that weighs about 55 pounds. And you literally stack them together like giant Lego blocks. If you need more range, you just click another battery block onto the stack.
And, the physics of making that safe for a consumer or like a delivery driver to handle are incredibly complex. You are dealing with massive amounts of stored energy.
Yeah, how do they keep people from just zapping themselves?
Well, these units use what's called blind mate high voltage connectors. The software in the units actually performs a really complex handshake protocol before any actual power is allowed to flow between the stacked blocks.
Oh, so it checks to make sure it's safe first.
Exactly, ensuring nobody gets shocked while they're snapping these 70-pound blocks together.
That's brilliant. Let's look at the actual output, though, based on the data from BeeCharged EV, who actually utilizes this equipment out in the field. A single Roadie battery unit holds about 3.45 kilowatt hours of total energy, with about 3.35 of that being usable.
And here's the critical part about how it delivers that energy. The charger blasts out up to 20 kilowatts of power, running anywhere from 150 to 500 volts of direct current, or DC.
Okay, for those of us who don't speak in electrical engineering terms, why does it matter that it's direct current? Like, why is that a big deal?
It matters immensely for speed. See, when you plug your EV into a standard level 1 outlet at home, you are using alternating current, or AC.
Right, just normal house power.
Yeah, and the car has to take that AC power and pass it through its own internal onboard converter to change it into DC power, because batteries can only store DC. That internal converter is a massive bottleneck. But the SparkCharge unit outputs DC directly, so it completely bypasses the car's internal converter and shoves the energy straight into the battery pack.
Oh, I get it. So my car's internal converter is basically a narrow funnel, and the SparkCharge unit just rips the funnel out and uses a fire hose.
That is a brilliant way to picture it, actually. And because it bypasses the funnel, it delivers about 10 to 13 miles of range in just 10 minutes.
Wow.
Yeah, that is a mile of range every 60 seconds, which is roughly 14 times faster than that standard level 1 charger you might plug into a wall outlet.
So it's really not designed to fill your car up to 100%. It's designed to give you that critical burst of energy to get you home or just to a permanent fast charging station.
Exactly.
It's literally Uber Eats for EV range. And the business model entirely reflects that. SparkCharge has an app called Currently.
Yeah.
They have raised $30 million in funding, including $7 million recently from the venture fund Cleveland Avenue, just to scale this app.
And their pricing model is built entirely around convenience, right? It's about avoiding the public charging infrastructure.
Right, because nobody wants to sit in a sketchy parking lot at midnight.
Exactly. So they have tiers ranging from a base fee of $4.99 a month plus 69 cents per kilowatt hour up to a premium $29.99 a month tier where the energy cost drops to 51 cents per kilowatt hour.
And people are absolutely paying for it. I mean, they have already delivered over 250,000 miles of range in major cities like Dallas, Los Angeles, and San Francisco.
It's huge in urban centers.
It is. But it's not just for consumers stuck in traffic. State agencies in Ohio are actually partnering with a company called EV United to use this exact technology to build a portable EV infrastructure network for their state fleets.
Yeah, and look at the unit economics for a government fleet manager there. I mean, government mandates are forcing agencies to adopt electric vans, but government utility grid upgrades move at an absolutely glacial pace. So a fleet manager might be trapped between a mandate to deploy 10 electric vans today and an 18-month wait for a trenching permit to install the actual chargers.
Talk about a rock and a hard place.
Right. So with SparkCharge, you bypass the grid and the bureaucracy entirely. You literally just wheel the power to the vans every night.
But, okay, let's play devil's advocate. SparkCharge is great for emergencies or, like you said, a closed fleet. But you cannot run a massive retail parking lot or a busy gas station with a guy sweating in a van hauling 70-pound suitcases back and forth to recharge them.
No, absolutely not.
The logistics of moving thousands of pounds of batteries around a city constantly, it just collapses at scale. To solve the retail problem, you have to stop moving the battery and instead fix it in place.
Which is exactly the realization a company called FreeWire came to. And what's fascinating here is that FreeWire actually started out doing the highly mobile trucking batteries around as a subscription model.
Oh, really? I didn't know that.
Yeah, they learned the hard way that the physics of mobile energy at scale are just brutal. So they pivoted.
And here's where it gets really interesting. They pivoted to something called the boost charger. So instead of a suitcase, picture something about the size of a standard phone booth. They deploy these at gas stations, parking garages, and retail stores as what they call pop-up installations.
The defining innovation of the boost charger is that it contains its own massive internal battery. It is essentially a giant energy buffer.
So it's like filling a huge water tower using a tiny garden hose all night, just so you can open the floodgates for 10 minutes when a thirsty car pulls up.
Yes, that's exactly it. And understanding the commercial utility billing behind that water tower analogy is honestly the single biggest aha moment of this entire deep dive.
Okay, tell me more about that.
Well, utilities don't just bill commercial properties for the total amount of electricity they use. They apply something called a peak demand charge.
Okay, break that down for me. What exactly is a peak demand charge?
It is a massive fee based on the highest rate of energy drawn at any single 15-minute window during the entire month.
Like 15 minutes? Out of the whole month?
Yes. So if a gas station installs a traditional 150 kilowatt fast charger, the moment an EV plugs in, the station's energy draw spikes to the moon. And the utility company penalizes them for that massive spike with a peak demand charge that can utterly destroy the station's profit margins for the entire month.
Oh, wow. So because the FreeWire unit has an internal battery, it avoids that spike entirely.
Exactly.
It just plugs into the existing low-voltage electrical grid, the tiny garden hose, basically.
Yeah.
And it sits there, trickling power in from the grid over 8 hours to slowly fill its internal battery. So the utility company never sees a massive spike.
You got it.
Then, when an EV pulls up, the FreeWire unit acts like a high-powered DC fast charger, blasting that stored energy directly into the car.
It solves the gridlock problem and the commercial billing problem simultaneously. It doesn't need the massive, expensive grid upgrades that take months to permit. Now, obviously, because it has all those internal batteries, the upfront cost of the unit is about 30% higher than a traditional charger.
Yeah, that makes sense.
However, it saves the operator up to 70% in long-term operational costs, specifically because they avoid those peak demand charges from the utility company.
That is a huge return on investment. Plus, FreeWire has evolved into offering business services, too. Like, retailers can use the software integrated into the charger's screen to analyze demographics and actually market directly to the drivers while they stand there charging.
It's a captive audience.
Right. So we have Spark Charge, handling a mobile app, on-demand deliveries in urban centers. We have FreeWire acting as a pop-up buffer for retail spots avoiding grid upgrades. But there is still a massive hole in this safety net.
Yeah, the rural problem.
Exactly. What happens when a driver is deeply stranded on the side of a rural highway, miles out of range of a currently app delivery, and nowhere near a FreeWire phone booth?
Well, that brings us to the emergency roadside assistance market. And to be clear, this is a massive, lucrative business. The vehicle roadside assistance market is projected to reach $35 billion globally by 2030.
That's B with a billion.
B with a billion. AAA is acutely aware of this shift, and they have been aggressively expanding their mobile EV charging pilot programs. They are now in 24 cities, recently adding places like Walnut Creek, California.
Also Columbus, Ohio, and Boise, Idaho. They're really spreading out.
Yeah, they are. But when you look at the AAA evaluation reports of these pilot programs, you uncover this striking paradox. To rescue these stranded zero-emission electric vehicles, AAA is relying on gasoline-powered generators.
I was reading through the pilot program notes, and it honestly made me laugh out loud. It is the ultimate contradiction. We are literally using fossil fuels to jumpstart the green revolution.
It is deeply ironic. But, when you dig into the thermodynamics of a roadside rescue, you realize the engineers really don't have a choice right now. Gasoline is incredibly energy dense, it is shelf stable, and it is universally available.
You don't have to wait 8 hours to trickle charge a gas can.
Exactly. AAA evaluated the Blink mobile charging units, testing them on vehicles like the Tesla Model 3 and the Polestar 2. And the evolution of this equipment tells a brilliant story about practicality versus pure power.
Let's look at the numbers. Because Blink Generation 1 used a 12 kilowatt Champion gas generator. The whole setup weighed a massive 365 pounds.
Huge.
But it was powerful. In a 30-minute charge session, it would give a stranded EV about 19.25 miles of range. Now, compare that to the Generation 2 unit released in March 2023. Gen 2 uses a 7.5 kilowatt Simpson generator. It weighs 230 pounds, but it only gives 13.7 miles of range in that same 30 minutes.
What's fascinating here is this raises a critical question. Why would an engineering team deliberately design a next-generation product that provides significantly less charging range to the stranded customer?
Right. I assume it has absolutely nothing to do with the battery technology itself and everything to do with the reality of a technician standing on the side of a noisy, dangerous highway in the pouring rain.
Exactly. The Gen 1 unit was incredibly heavy. At 365 pounds, it was just a beast for a single technician to maneuver. Furthermore, the way the EV charging unit was mounted physically blocked the standard 120-volt AC outlets on the generator.
Oh, so they couldn't plug anything else into it.
Right. Which means the tow truck driver couldn't plug in a floodlight or an impact wrench or any other tools they might need at a crash scene. The generator could only do one thing.
Yeah, it completely monopolized the equipment.
Yes, but the biggest issue was the physical stress on the machine. Gen 1 had to run at an 80% sustained maximum load to achieve that high output. And a generator running at 80% capacity is basically screaming.
It's working so hard.
It is vibrating violently, throwing off immense heat and creating deafening noise. AAA actually mandated a 5-foot safety clearance on all sides just to deal with the thermal exhaust.
Wow. You just can't have a giant, screaming hot piece of metal taking up a 5-foot radius on a narrow highway shoulder while cars are flying by at 75 miles an hour. It's a safety nightmare.
It is. So the Gen 2 unit sacrifices raw power for operational reality. It drops 135 pounds of weight. It is freestanding with wheels and a flip-up handle, so one technician can just wheel it around easily.
And the charger doesn't block the other outlets anymore.
Nope. But most importantly, it is rated differently. It runs at a 100% sustained load safely, drawing 32 amps.
Wait, hold on. If it's running at 100% load, isn't that worse than 80%? I mean, shouldn't it be louder?
It sounds counterintuitive, I know, but no. The Gen 2 is designed specifically so that its maximum 100% rating is actually a safe, quiet cruising speed. It is engineered to purr along at that output indefinitely, without generating dangerous thermal zones or deafening the technician.
Okay, that makes sense. It's also got Wi-Fi built in.
Right.
So the roadside provider can instantly calculate billing based on a flat fee or per usage during the rescue event.
Yeah, it's totally integrated.
So they sacrificed a few miles of speed for mobility, worker safety, and a much smaller, cooler footprint in the back of the rescue truck. It really proves that in the real world, the best technology isn't always the most powerful one on a spreadsheet.
Absolutely. It is a temporary bridge, using old world fuel to support new world tech, but it is entirely necessary to keep early adopters confident enough to make the switch while the grid catches up.
So what does this all mean for you? Well, if you are an EV driver or thinking about becoming one, the very concept of range anxiety is fundamentally shifting. It used to be this intense fear of a fixed geography like, what if I can't reach the plug?
Right.
But what we're seeing across all these sources is that the infrastructure is adapting to human behavior. The gas station model is just no longer the only way, whether it's a technician bringing you a stack of spark charge blocks via an app or a free wire pop-up charger appearing at your local grocery store without needing a trenching permit.
Or a tow truck driver pulling up with a quiet, efficient Blink gas generator.
Exactly. The infrastructure is actively hunting you down rather than you having to hunt it down.
And, if we connect this to the bigger picture, it leads to one final thought regarding the 2026 trends we started with. The Blink report highlighted the rapid rise of bidirectional charging, specifically V2G, which is vehicle to grid, and V2H, vehicle to home.
Meaning the car isn't just a battery that consumes power, it's a battery that can push power out to keep your house running during a blackout, or even sell energy back to the utility company during peak hours.
Yeah, that changes the entire paradigm. I mean, if every new car on the road is carrying a 400-mile battery pack capable of safely discharging massive amounts of power, how long until we don't need AAA's gas generators or SparkCharge's suitcases at all?
Oh, wow.
Will the next phase of EV innovation simply be peer-to-peer charging? Imagine a future where you pull over on the highway, take out a specialized bidirectional cable, and literally jump-start a stranded stranger's car using the XM range directly from your own EV's battery.
That is wild. So the network wouldn't just be mobile. The network would literally be us.
We are the infrastructure.
That is an incredible thought to leave on. The grid isn't just coming to you. Eventually, you are the grid. We want to thank you so much for joining us on this deep dive into the sources today. Keep exploring the evolving world of clean transportation. And remember, the next time you look for a place to fuel up, you might just find it's already looking for you.